that everyone who is watching this video is staying at a safe and a healthy situation right now. My name is Ziying. I'm the chef scientist of the company Prime Pharma. So today I'm here to present to everyone about my plan and my strategy on the new drug discovery for this current outbreak. So I believe that the most popular topic globally nowadays is about COVID-19, right? The very highly infectious disease that has already infected more than 3 million of people and already caused death in more than 250,000 of human death. So actually this disease is transmitted from Wuhan, China to the worldwide in just 3 months of time. So everyone of you can imagine that how highly infectious is this virus is, but most importantly is that there's currently no any vaccines or any antiviral drug that can control this virus. So this is the important thing right now. So as a scientist, my team and I, we have working very hard for the past few months in working on the drug discovery to control this disease. But that last week we just implement a very new approach into our research. We call it as computer-aided drug design, CADD. So this approach is actually a new technology so that it can help us to save much more of time, and it is very cost effective. This is the reason why we choose it and implement it into our research. So right now I will share with you about the drug development process. So so there's mainly 4 main process in drug discovery. So you can have a look at my laptop here. Right, so you can see the first one, we call it as the drug identification. So drug identification is the very first step in our drug design because we have chosen to use structure-based drug design. So the second one is lead identification, third one lead optimization, and the very last one preclinical and clinical trials. So in my presentation here, I will only focus on the first 2 processes, which is the target identification and also the lead identification. Alright, so everyone, so just for easier understanding, I have prepared a slide like this. So I will start with target identification. So among all the different approaches and ways, we have chosen X-ray crystallography to identify the structure of our target. So I will explain to you later on why we choose X-ray crystallography among the others. So here is just a very brief idea on what I will be talking about later. So the next process is about lead identification. So in lead identification, we have 4 steps. The first one is Pharmacofor Modeling. Second, molecular docking. Third one, virtual screening, and the very last one, de novo design. So these are the 4 steps that I will talk about later. Alright. We'll move into the very first process of drug development, which is target identification. So just for information, it is very, very important to identify the correct and accurate structure of target, so that only that we can have a so-called pocket for the ligand or for the drug to bind it to. So as I have mentioned earlier, we will use the X-ray crystallography to identify the structure of coronavirus. So in just simple words, in this technique, we will freeze the coronavirus in water, and then we will we will obtain the structure of the coronavirus by using X-ray. So we'll capture it from all perspectives so that we can get the every binding size, every structure in details. So I have said that we use X-ray crystallography instead of NMR or homology modeling. This is because our aim here is to get the structure of the coronavirus, but we are not aiming to visualize the binding of virus with other ligands. We just purely want the structure of the virus. That's why we have choose X-ray crystallography. After identifying the 3D structure of the target, we will now move into the very first step of lead identification, which is Pharmacofor Modeling. Okay, so Pharmacofor Modeling is actually a technique to identify the common structure from multiple known drugs that has been using in treating coronavirus right now. So the drugs such as ritonavir, chloroquine, hydroxychloroquine, and alpha interferons. So these are the drugs that has been using right now in treating coronavirus. So we will extract the structure of this drug and use computer technology to align them together and extract a new structure alignment, which we call it as pharmacophore. So this pharmacophore is actually representing the essential interaction between coronavirus and also the drug. So later in virtual screening step, we will use this pharmacophore as a model, and we will filter the similar drugs with similar structure from the PDB to get the drug. Okay guys, so right now I will show you a very simple picture that can explain Pharmacofor modeling in a simple way. Okay, so you can have a look here. So these are the 4 structures that we call it as multiple known drugs. So we will extract their structure in like this in different ways, and then we will combine these four structures together and get a new alignment, which is like this. So this is what we call pharmacophore. Okay, so this pharmacophore we will use it later in virtual screening and find the similar drugs that have this kind of structure. Okay, so is it clear? All right, so the next one I will talk about molecular docking. So before this, let me explain first. So molecular docking is actually another approach that we will insert 2 things. The first one is we will insert the rigid coronavirus receptor, and the second is the flexible ligands, which synthesized using computer technology. Okay, so both of these will be inserted into a docking program, and in the program the ligands, okay, so you can have a look now. Okay, you see the red color one? The ligand will move around the virus, which is the coronavirus. It will move around and find the best pocket for it to fit. Okay, so at the same time it will change its shape accordingly for itself to fit into the pocket. We can actually obtain 2 important things from docking. So the first one is the correct bound conformation, which we get it from the ligand, and the other one is we can actually predict the affinity of the binding between the virus and also the ligands. So actually docking is a very useful process in lead identification. Okay, now we'll move to the next step, which is virtual screening. So virtual screening is actually a very powerful screening which could help us to eliminate more than 100,000 of undesirable compounds and leaving us the suitable one for us to process. Okay, so in virtual screening we will insert the pharmacophore and also the ligand structure from docking into the program, and then in the program they will screen out all the undesirable one and leaving the similar structure, the similar drug from the database and for us. And now these are the lead compounds. Okay, so these are the lead compounds that we are looking for COVID-19. Okay, then the drug will be further tested in preclinical and clinical trials. Okay, last but not least, we have another team that we call it design team, who are responsible to design a completely new drug from scratch for COVID-19 by using de novo design. So they will use the data, the information from Pharmacofor modeling, from docking, and use it as the information for them to design the new drug. Okay, so in conclusion, apart from virtual screening, we also have de novo design in order for us to get the new drug. Not the new drug first, but the lead compound first. Okay, so I hope that our team and us, we will successfully get the drug and help to save everyone from this disease. So thank you everyone for watching. I hope that I have improved your understanding or help you to understand more about drug discovery for this COVID-19. So please stay safe and Hope that everyone will practice your personal hygiene. Together we fight the virus. Thank you.